So I will present about introduction. The product in our project use is food container. The function of the food container is packing for preservation, storage, and transportation. And the material used in the food container is using polypropylene, we call it PP material. The material is high thermal and chemical resistant and it is reusable. And for the manufacturing process, we will use injection molding technology because it is high volume, precise, and cost effective.
The product we choose for this project is thin wall injection molded plastic food container. The usage of this is to package food, meal preparation, and reusable and multi-use storage. The design of this container is tapered rectangular shape enables stacking and high-speed automated production. So for material selection, the primary material is the polypropylene. It has high melting point which is about 160 to 170 degrees Celsius. It is resistant to moisture, lipids, and chemicals. It is microwave and refrigerator safe, tough and flexible, excellent flowability, and recyclable. For the design and geometry of this container, its shape is tapered or trapezoidal design to enhance stackability and nesting. The external dimensions for the height is 60 mm, the base is 105 mm times 150 mm, the lid is 135 mm times 180 mm. For the internal dimension, the upper opening has a dimension of 170 mm times 135 mm, the lower base is 105 mm times 75 mm. For the wall design, it's looped inward for structural strength and stacking stability is to prevent buckling under vertical loads. For the manufacturing process of this container, the process used is injection molding. Is the primary manufacturing method used for the plastic food container. It is suitable for producing complex uniform and thin wall plastic parts. As the material is polypropylene, it is ideal for injection molding due to excellent flowability and low melt viscosity. It enables high speed, high volume, and cost efficient productions. For mold design considerations, for the mold type, it is two-plate mold made from hardened tool steel, multi-cavity mold used for high volume production, and for the key design elements for this process is rough angle, thin wall design, flow channels, gate pipe, and cooling channels. So for the injection molding process, the first is material preparation. Food grade polypropylene pellets dried before processing. Pellets loaded into hopper of the injection molding machines. The second will be melting and plasticizing. Pellets melted in a heated barrel. Rotating screw transports, melts, mixes, and homogenizes the material. And third is the injection into mold cavity. Molten polypropylene injected into steel mold cavity under high pressure. Fast injection speed is essential for thin wall product to prevent premature cooling. The fourth is packing and holding. It is to hold the pressure applied after filling and compensate for shrinkage and improve dimensional accuracy. The fifth is cooling and solidification. The cooling time is 8 to 12 seconds. The mold includes cooling channels with circulating water for rapid heat removal. The sixth is mold opening and injection. Mold opens and ejector pins push the solidified part out. Ejector location design is critical to avoid deformation, especially at thin or corner sections. The last is the post-processing, which is trimming to remove flash or excess materials, visual inspection, fit testing with lead, and packaging with labeling. For the cycle time and productivity, the cycle time of this process is about 25 to 35 seconds. The output capacity is up to 700 to 1000 units per hour with an 8 cavity mold under continuous operation. This is influenced by mold capacity, cavity count, and cooling efficiency. For the automation and quality control, the automation tools used in this process includes robotics arm for part removal and stacking, inline cameras and sensors for detecting such as surface defects, warpage, and dimensional errors. And for the material control of this process, which is the melt flow index MFI monitoring detects the resin inconsistencies. For quality inspection, it uses ultrasonic gauge, seal test, and drop and pressure resistant tests.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amiruddin bin Zulkifli. So, for a problem statement, in the manufacturing industry, food container plays an important role in the storage, packaging, and transportation of consumable goods. However, the production of traditional food container, especially those made from single-use plastic, raise several sustainability concerns. These include high energy consumption, significant carbon emissions, excess material waste, and long-term environmental pollution due to non-biodegradable materials. And current manufacturing techniques such as thermoforming and injection molding are often chosen for their cost effectiveness and efficiency. However, these methods rely heavily on fossil fuels and produce large amount of post-consumer waste. In addition, many plastic containers made using these techniques are not easily recyclable, which contribute to the global plastic pollution crisis. Because of this challenge, it is necessary to explore alternative material like biodegradable polymers or recycled plastic and to improve manufacturing process to support sustainability development. And this research focus on identifying the issue in current food container production and evaluating how sustainable materials and processes can help reduce environmental, social, and economic impact.
Next is about the sustainable element. There are five sectors in the sustainable element. First is application, which use the material that can save energy and maximize the output. Second is the practicality. Some challenge have to be overcome to be doable. Third is the economical. Through sustainability, it can maximize the growth of the profit margin by using replaced material of the company. The fourth one is the social. The element social includes the social responsibility of health, safety towards the community and the workers. The last one is the environmental, where the waste products such as gas or chemical from the factory should have to treated properly and in a proper way to dispose.
So for the conclusion for this project, polypropylene food container is analysis focused on its smart design and efficient manufacturing process. For this material, it can make the container can be used for microwave, freezer, and dishwashers, and it comply with food safety law. And for the manufacturing process, inline control has allowed for high volume production. It can rack of up to 1,000 units per hour. And this food container is balance of performance, cost efficiency, and environmentally responsibility. And it is a model of sustainable industry design.